You might think you know the shape of the Earth, right? I mean, it's something we learn almost from day one, kindergarten stuff. Foundational. Something most of us just easily, well, we take it for granted. But what if I told you that despite centuries of science and even ancient texts kind of hinting at it, there's still a surprising amount of talk about it, even today. So today, we're diving deep into exactly that. It's a common question, one debated for ages, and yeah, still sparks conversation for some. Is the Earth flat or is it spherical? We're going to navigate through, different viewpoints. From those really influential ancient writings all the way to modern science, trying to get to the core of it.
What's really fascinating, we get into this deep dive, is seeing how these different ways of looking at it, ancient perspective, scientific methods, they actually they line up. They converge on a pretty consistent understanding. We'll explore how historical writings, specific verses that often get twisted, frankly, and just solid scientific findings, all shed light on this common question. The goal here is clarity, a full picture of why the answer's been, well, pretty settled for thousands of years for anyone who really looks at the evidence.
And this isn't just about, like, geometry, is it, or physics. It's more about understanding how different kinds of knowledge work together. Spiritual insights, observation, poetry, alongside that hard empirical evidence, how it all helps us grasp the world. So what does this all mean for you listening in? If you're curious about how we build knowledge, how it changes, and maybe how it holds up against beliefs that just persist.
Okay, let's unpack this. Let's start by looking at some of those really influential ancient texts, specifically biblical writings. Because, well, a common question people ask is, do these texts actually teach a flat Earth, or even imply it? It comes up a lot when people talk about historical worldview, so getting the nuance right here is, I think, pretty important.
That's a great place to start. A lot of the confusion you see comes down to something called phenomenological language. Basically, ancient writings often describe things how they look from Earth, like how a person standing there would see them, not as precise scientific models. Think about it. We still say the sun rises and sets, don't we?
Yeah, every day. Even though we know it's the Earth spinning, it's describing what we perceive.
Right. Okay. It's the experience, not the mechanics behind it.
Yeah.
So keeping that in mind, what about a verse like Isaiah 40.22? It mentions the circle of the Earth. I think a lot of people might just picture a flat coin, a round disc. Is that what the original text suggests?
Not really, no. The Hebrew word used there, chug, that's key. While it can mean circle, it more strongly implies roundness, curvature, like a vault or a sphere's boundary. Think of drawing with a compass, you make a circle, sure. But the Earth is a sphere. And viewed from space, or even just seeing the horizon, it presents a circular boundary.
Ah, okay.
So scholars generally agree it conveys three-dimensional roundness, not just a flat two-dimensional shape, more like a globe than a dinner plate.
So a global form, a rounded shape, not a flat disc. That distinction is huge. And what about Job 26.7? That one always gets me. It's so poetic, but also insightful. He stretcheth out the north over the empty place, and hangeth the earth upon nothing. What do we make of that?
That verse is, frankly, astonishing for its time.
Yeah.
Hangeth the earth upon nothing. I mean, that strongly suggests gravitational suspension. This idea of the Earth just floating freely in space, no visible supports.
Right.
It fits perfectly with how we understand planets are held in orbit now.
Yeah.
And it completely cuts against any idea of Earth resting on pillars or a giant turtle or anything physical holding it up. It points to this maybe intuitive grasp of Earth being alone, unsupported in the cosmos.
Gravitational suspension. Thousands of years before Newton. Wow, that really flips the script on what people assume folks back then understood. Are there other hints like that in these writings, pointing towards a spherical, maybe vast world?
Oh, absolutely. Look at Proverbs 8.27. It says, when he prepared the heavens, I was there. When he set a compass upon the face of the depth. Again, that word compass suggests drawing a circle, defining a boundary, implying a circular or spherical limit, a shape drawn on the vastness. It's about creating a defined, enclosed, and therefore rounded space.
Okay. And then we have to talk about the big one, four corners of the earth. Revelation 7.1. I mean, hearing four corners today, it sounds definitely like a square, flat world, doesn't it? How do we square that circle, so to speak?
Yeah, that's a classic. And it's a perfect example of figurative language. It's not literal geology. It's just a poetic way of saying the four cardinal directions, north, south, east, west. It signifies the entire world, global reach.
Like saying from every corner of the globe.
Exactly. We see it used like that elsewhere. Isaiah 11.12 talks about gathering people from the four corners of the earth, clearly meaning from all over the planet.
Right.
It's about scope, universality. not a literal square planet with edges.
Okay.
And similarly, when Psalm 104.5 talks about foundations not be removed, that's poetry about permanence, stability, God's enduring creation, not literal pillars holding up a flat disk.
So four corners isn't literal. That clears up quite a bit, actually. But what about someone who really wants to find a flat earth in these texts? They might point to the firmament in Genesis 1. Isn't that described sometimes as like a solid dome?
Well, the term firmament, the Hebrew rakia in Genesis 1, it refers to the expanse, the vault separating the waters above from the waters below. It's about bringing order to creation, establishing structure, the sky, the atmosphere, as this vast, ordered space. It's not describing a hard, physical dome like a snow globe lid.
Mm.
And on geocentrism, Earth at the center, the text just described the sun's movement from how it looks from Earth.
Yeah.
Which is totally natural. Psalm 19.6, for instance. It's beautiful poetry about the sun's journey across the sky. It's not making a scientific claim about orbital mechanics. It's about what you see standing here.
And the idea of literal pillars of the earth, that sounds very much like a flat earth needing support beams. What about those mentions in Job or Samuel?
Those are absolutely metaphors. Metaphors for God's power, his sustaining force, the stability of creation. You see it in Job 9.6, 1 Samuel 2.8. They aren't architectural drawings of structural supports for a physical earth. They symbolize divine strength, the reliability of the natural order. It's about the power upholding the world, not physical columns holding it up. So ultimately, when we look closely at these ancient writings, the language is observational, it's deeply symbolic, and it's actually remarkably consistent with a spherical model. It doesn't contradict it. In fact, as we've seen, some verses like Job's hangeth the earth upon nothing or Isaiah's circle of the earth, they actually seem to imply curvature and suspension, things that fit perfectly with a round earth. The whole idea that these texts teach a flat earth, that's mostly a modern misunderstanding, reading ancient, often poetic language way too literally.
Okay, so the ancient texts, understood in context, not only don't contradict a spherical earth, but some parts might even, subtly suggest it. That's a really powerful point that gets lost sometimes. But of course, the real nail in the coffin for the flat earth idea has to be centuries of direct, repeatable, scientific observation, doesn't it? Moving from those interpretations to modern evidence, this is where it gets really interesting. Science has just piled up this mountain of evidence verified over centuries. So what does that overwhelming evidence actually show?
Precisely. And the scientific evidence for a spherical Earth isn't just, strong. It's overwhelming. And it's overwhelming because these proofs are repeatable. They're falsifiable, meaning you could disprove them if they were wrong, and they've been verified globally. They aren't just random observations. They're interconnected proofs that all point to the same shape for our world.
Can you walk us through some of the big ones, the really undeniable proofs? Let's start with maybe a lunar eclipse. Most people have seen one, or pictures at least. How does that prove Earth's shape?
Okay, so during a lunar eclipse, Earth passes right between the sun and moon, and it casts its shadow on the moon. Now, that shadow is always curved, always consistently round, no matter where you are on Earth observing it or what time it happens.
Always a curve.
Always a curve. And that perfectly circular shadow is exactly what a sphere casts when light hits it. If Earth were a flat disk, well, depending on the angle of the sun, sometimes you'd expect to see maybe an oval shadow or even a straight line. But we never, ever do. NASA's got tons of data on this, obviously.
That curved shadow.
Yeah.
Yeah, that's such a clear visual. And what about the classic ship disappearing over the horizon? Anyone who's, spent time by the sea has probably noticed it. But it's not just a trick of the eye, right? It's actual proof of curvature. How does that work as evidence?
Yeah, it's maybe one of the most intuitive proofs. When a ship sails away, it doesn't just get smaller and smaller until, poof, it's gone. Instead, you see the hull disappear first, then maybe the deck structures, then the mast. Finally, the very top vanishes.
Bottom first, then top.
Exactly. And that happens because the ship is literally sailing over the curve of the Earth.
Mm-hmm.
The curve hides the lower parts before the higher parts.
Yeah.
If Earth were flat, the whole ship would just shrink proportionally, right? All parts visible until it was just too tiny to see. The Royal Institution, places like that, have demonstrated this basic physics for ages. Simple, compelling.
The curve literally hiding the bottom of the ship first.
Yeah.
Wow, yeah. That is compelling. What about looking up at the night sky? Do the stars tell us anything?
They do. Constellation shifts. If you travel a significant distance north or south, you'll notice different stars become visible. And the stars you can see change their altitude in the sky. Polaris, the North Star, is a great example.
Mm-hmm.
The further north you go, the higher Polaris appears, right overhead at the North Pole. But travel south past the equator. It disappears completely below the horizon.
This change in what stars you see and how high they are only works on a curved surface. On a flat plane, everyone should theoretically see the same stars, just maybe dimmer or smaller, further away.
Mm.
Sky and Telescope, NASA, they explain this really well.
And then, I guess, the most direct evidence of all, just looking at it,
Yeah.
seeing it.
Exactly. Satellite imagery. Since the space age began, we've had thousands and thousands of photos of Earth from orbit. Rockets, satellites, the International Space Station, I mean, countless sources.
Right.
And every single picture, without exception, shows a sphere. The NASA Earth Observatory, European Space Agency, commercial satellites, they all show the same thing.
Mhm.
It's kind of hard to argue with a direct photo, isn't it? Especially from so many independent eyes.
It really is. What about practical stuff? Does the Earth being a sphere affect how we, say, fly around the world?
Oh, absolutely. That brings us to flight path geometry. It's a fantastic real-world application. Airlines use what they call great circle routes for long-haul flights. These aren't straight lines on your typical flat map. They're the shortest distance between 2 points on a sphere, so they often look like curved paths on a flat projection. Aviation charts, like the ones from ICO, are all based on spherical math. If you tried to plot these actual flight paths on a flat Earth map, they just wouldn't make sense. Pilots fly these curved routes daily because they save time and fuel.
And the force that keeps our feet on the ground, gravity. How does its behavior tell us the Earth is round?
Gravity measurements, yeah, another key piece. We know gravity pulls towards the center of mass. On a spherical Earth, that means down is always towards the center of the planet, no matter where you're standing. That's why things fall straight down.
Makes sense.
But imagine a flat disk. Where's the center of mass? Presumably somewhere in the middle of the disk, right? So if you were standing near the edge of this flat Earth, gravity wouldn't pull you straight down towards the surface you're on. It would pull you kind of sideways towards the center of the disk. You'd feel like you were constantly on a slope trying to fall towards the middle,
Oh, interesting.
which is clearly not what we experience. Gravity pulls us down, perpendicular to the ground beneath our feet, everywhere. That's a direct result of standing on a massive sphere. NIST, the folks who standardize measurements, have tons of data on gravity variations across the globe, all consistent with the sphere.
And we can even look way back, right, to ancient times for early scientific proof. Centuries before satellites. I'm thinking of Eratosthenes.
Yes, Eratosthenes' experiment.
Yeah.
A brilliant, elegant, early proof. He was a Greek mathematician over 2,000 years ago. He calculated Earth's circumference with pretty amazing accuracy just by noticing that the sun's rays cast different shadow angles at noon in two different cities, Syene and Alexandria, on the same day.
Just with shadows.
Just with shadows, and knowing the distance between the cities. He knew that in Syene, on the summer solstice, the sun was directly overhead at noon, no shadow in a deep well. But in Alexandria, further north, a vertical stick did cast a shadow. That difference in shadow angle between two locations a known distance apart, it only works if the surface between them is curved. On a flat Earth, parallel sun rays would mean the shadow angle is the same everywhere at the same time. It's a fantastic piece of early ingenuity. So if you pull all these threads together, the lunar eclipses, the ship's vanishing hull first, the changing stars, the satellite photos, the flight paths, gravity, even Eratosthenes' old experiment. The spherical model doesn't just explain one or two of these things. It elegantly accounts for all of them. Plus, it seamlessly explains time zones, why we have seasons, and the simple fact that you can sail or fly in one direction and eventually get back to where you started circumnavigation.
And that really is the key difference, isn't it? Because no flat Earth model, none of them, can actually explain all these interconnected, proven facts without resorting to, well...
Wild conspiracies.
Yeah, or just ignoring inconvenient data, invoking bizarre physics, or claiming it's all fake. It's like trying to force a square peg into a round hole, but the hole is, like, the entire observable universe. So... given all this evidence, ancient and modern piled high, you might be asking why? Why do some people still genuinely believe the Earth is flat? And this raises a really important question, one that goes beyond just physics and into, well, human psychology and how groups work.
It's definitely a complex thing, and it says a lot about how beliefs get formed and, maybe more importantly, how they get defended. Even with overwhelming evidence, the flat Earth idea persists. Why? It seems to be a mix of things. Deeply held worldviews, maybe a strong sense of group identity, and just basic misinterpretations of science, and sometimes of those ancient texts we talked about. One really big factor, which comes up in studies of these kinds of beliefs, is a profound distrust of authority.
Like distrusting NASA scientists, the media.
Exactly. NASA, academics, mainstream news, sometimes even just basic scientific consensus. If you start from a place of deep skepticism towards those institutions,
then maybe you're more open to alternative explanations, even if they seem far-fetched.
Precisely. And that skepticism often leads people into what some researchers call a conspiracy ecosystem.
Mm.
Flat Earth belief rarely exists in a vacuum. It's often connected to and reinforced by other theories. The moon landing was fake, space travel isn't real, maybe broader ideas about global elites hiding the truth. It's like a package deal sometimes.
Mm-hmm.
Then there's the social identity piece, which is huge. Online communities, forums, they provide this really strong sense of belonging, validation. People feel like they've woken up to something important, something the rest of the world, the sheeple, are missing.
So it sounds like there's a really strong emotional pull, a social connection. It's not just arguing about facts around a table.
Oh, absolutely not. And beyond the social side, there's often just a fundamental misunderstanding of the science involved. Misreading basic optics, ignoring physics principles, or seeing natural phenomena and interpreting them through a really flawed lens. And like we discussed earlier, for some, religious literalism is a big factor, taking poetic or observational verses as literal science, which creates a conflict that isn't actually there in the original context.
It's fascinating how much psychology seems to be driving this persistence. It's often not really about the facts themselves, is it?
Not primarily, no. Psychologically, you see several common patterns. There's denialism, actively rejecting facts, sticking to the belief even when shown overwhelming evidence against it. Then there's the group loyalty. A person's identity gets really wrapped up in being part of this contrarian group. That reinforces the echo chamber and makes it incredibly hard for contradictory information to even get a hearing, let alone be accepted.
And how does that affect the information they look for, or maybe the information they ignore?
That's cognitive bias, hard at work, especially confirmation bias. We all do it to some extent. But here it's pronounced, people instinctively seek out stuff that confirms what they already believe.
Right.
And they ignore, dismiss, or find ways to explain away anything that challenges it. This just makes the flat Earth narrative stronger and stronger within the group. It's a self-feeding loop. And finally, don't underestimate the emotional appeal. The feeling of having special knowledge, of being uniquely insightful, of having had an awakening that can be incredibly powerful and validating. It anchors the belief emotionally, making it resistant to purely factual arguments. You see these dynamics discussed in research from places like the University of Chicago on belief persistence, Pew Research on science skepticism, and articles in places like The Atlantic looking at the psychology behind conspiracy theories.
So it's really this complicated mix. Psychological defenses, the power of group identity, deep-seated distrust. It's not just a simple disagreement about planetary shape. That really puts the persistence of the belief in a whole different light.
Yeah. Ultimately, what this deep dive shows us is that the Earth is unequivocally a sphere. That conclusion is consistently backed up. It's supported by ancient observational language, which, when you understand the context, points towards curvature and suspension. And it's supported by just a massive amount of reproducible, globally verified scientific evidence from all sorts of different fields.
And when you weigh that evidence for a globe, I mean, the probability based on everything we know have to be over 99.9%, right? You weigh that against the roots of the flat Earth claims, which, as we've seen, aren't really about a careful reading of scripture or rigorous science. They're grounded in social dynamics, psychology, misunderstanding. The probability there is, what, less than 0.1%? The conclusion is pretty stark. This whole journey, looking at ancient texts, looking at modern science, it really highlights how easily our beliefs can be shaped, not just by facts, but by our communities, our perspectives, who we trust. It kind of makes you wonder, doesn't it? What other common questions do we answer based on assumptions, maybe? Or habit? Instead of really digging into all the evidence and understanding why some beliefs hang on, even when reality points elsewhere.
Thank you for joining us on this deep dive into what the Earth and maybe human belief itself reveals.